And we're recording. Awesome. Kia ora koutou katoa. Ko Joe Alam. Aho, my name's Joe. This is the beginning of RaC Guild Townhall number 10. And it's Wednesday, the 2nd of April. And we've got an awesome presentation today that we've been looking forward to. It's a great big piece of work been done over in Washington, DC. We'll have time for questions later, but we've got a panel of presenters, actually, not just one presenter today, to talk about the work that's being done to explore, as many people are exploring at the moment, AI-powered rules as code, particularly with the public benefits policy in the US. So leading out that project is Ariel, and there's a team, Pina, Jason and Kenny. I think we have Jason and Kenny with us as well this morning from Georgetown University. So without further ado, take it away, guys, and then we'll ask some questions at the end. Thank you.
Well, thank you so much. It's great to be here. I'm going to take over presenting. And everyone can see my slides, yes? Well, it's great to be talking to all of you who are in the future. We're back here on April 1st still in the States, and it's great to have this call at a time where we can join across international date lines to share on rules as code. I've come to some of these before and have really enjoyed meeting many of you and learning from your work. We are joining you from Georgetown University, and we'll be sharing work that has happened as a collaboration across multiple research centers, includes student, faculty, and staff members. Jason, Kenny, and I are just part of the team who've been doing this work. So excited to share it with you. To give you a little bit of background on where we're coming from and what we do, I'm the Senior Director for the Digital Benefits Network. We're a program of the Beck Center for Social Impact and Innovation, which is part of Georgetown. We support government in delivering public benefits and services and technology that are accessible, effective, and equitable in order to ultimately increase economic opportunity. That means that we work across key benefits programs, including food and nutrition supports, health insurance, cash assistance, childcare, and unemployment insurance. And across those programs, we work to identify shared challenges and opportunities and amplify strategies to enable equitable and effective implementation. You can learn more about our work on our website, digitalbenefitsnetwork.org. This research and our work on rules as code for the last several years has been a collaboration with the Massive Data Institute, which is another research center housed in our McCourt School of Public Policy. And the Massive Data Institute is an interdisciplinary research institute that connects experts across computer science, data science, public health, public policy, and social science to tackle societal scale issues and impact public policy in ways that improve people's lives through responsible evidence-based research. We have been working together on rules as code work for the last 2 years, but the Digital Benefits Network actually started our research on rules as code back in 21. We published our first paper in 22. We hosted our first rules as code demo day that summer, and we've continued to host other events. We have a community of practice that's mostly US practitioners, but we definitely have some Canadian and European friends, and I know some of you lurk in there as well. We're really happy to share our latest research with you that comes out of our Policy to Code prototyping challenge, which we'll share just a little bit more about in a minute. And this year, we're also continuing new research, talking more directly with state government who do most of the benefits delivery in the United States, and really talking to them more about their eligibility and enrollment systems and more about like their willingness and interest in rules as code and the challenges they currently have in administering those systems. So today, we'll be sharing our latest work called AI-Powered Rules as Code, and how we've been using large language models to explore if we can expedite the translation of public benefits policies into rules as code. This work, as I mentioned, comes from our Policy to Code prototyping challenge. We ran the challenge, the recruitment in the spring last year, and then the cohort of teams met from June to August, and then culminated in demo day in September. We had 12 teams cross-sector who participated. On our website, beckcenter.org/policy to code, you can see all of the demos and outputs from the teams. Really fun, and the demo day was in person, so we also have fun photos of everyone together, but really a wonderful event, and kind of built even further community around rules as code. I'm going to pass to Jason to introduce our team from Policy to Code and tell you more about our research.
Thanks, Ariel. So this is our team who's behind the report that we just released. We call ourselves Hoyas Lex Ad Codex, and in Latin that's Hoyas, which is Georgetown's mascot, Rules as Code. As Ariel mentioned, we're a collaboration of the Beck Center, the Massive Data Institute, and as well as another center, the Center for Security and Emerging Technology here at Georgetown. And you'll see a couple of our teammates who are missing, an undergraduate computer science student, Alessandra, as well as a professor of computer science and public policy, Lisa Singh, who we also work very closely with. And then you'll see Ariel Kennan there as well. Next slide, please. So as part of our report that we're discussing today, we ran experiments across two policies. One of the policies was the food assistance policy in the US that's called SNAP. And we also ran our experiments on Medicaid, which is our federal health insurance program. For those of you who don't know, both of those policies are federal programs, but administered by each state in the US. So we looked at the policies across 7 different states, and we chose our states to get geographic variety, as well as to look at states with different eligibility rules and to see how our experiments may work differently across those different policies. We ran our experiments using different LLMs. We looked at the ChatGPT and Gemini chatbots and the GPT-4o API, which is also OpenAI's API. Next slide. So these are the 4 experiments that are part of our work. Our first experiment asked the LLMs different eligibility questions, and we sought to understand how well the LLMs could answer those questions just based on their training data. The second experiment looked at very similar questions, and we assisted the LLM by providing the formal policy documents that we pulled from the authoritative sources from the states themselves, and we saw whether or not the LLMs could answer the questions better when given the documents. The third experiment looked at how well the LLMs could generate programmable rules using a template. And we tested that both using policy documents that we fed into the LLMs and without. And finally, our fourth experiment looked at how well these models could produce software code as a baseline for eligibility and enrollment systems. Next slide. So I want to share with you a little bit about experiment 1 before passing it back to Ariel. Our first experiment, this is our methodology, and as I mentioned, we were looking to understand how well the LLMs could answer different questions about the policies, and we evaluated the responses we got back based on 3 different criteria. So we looked at whether the responses were provided current and state-specific information. That state-specific criteria is very important, and as I mentioned, given that the states all have slightly different policies. We also evaluated the responses based on how complete they were, as well as how relevant they were. And next slide. And what we saw was that the 3 models actually didn't show very major differences across these 3 criteria. They all performed reasonably well with regard to whether they provided state-specific or current information and providing relevant responses, but they had a pretty big drop-off in relation to how complete responses they provided. And one of the things we were concerned about in our research was that if this LLMs were providing incomplete responses, they may miss eligibility rules that were really important for determining the eligibility for these programs. So that's something that we sought to highlight as one of the takeaways from this experiment. I'll pass it back to Ariel to discuss the experiment. Actually, sorry, one more slide here. One other thing I wanted to point out was that the different policies didn't have very different outcomes in terms of how accurate the LLMs responded about them, though we did say slightly higher scores for the health insurance policy, Medicaid, than we saw for the food assistance program, SNAP. So that's what we wanted to highlight here. And now I'll pass it back to Ariel.
Jason, do you want to take Joe's question in the chat about how many prompts this is based on?
Yes. I don't have the number on the top of my head right now. It is in the report. But for the first two experiments, we used, I would say, approximately 25 prompts per state policy. And so we looked at 14 different policies when you look at the state and policy combinations. So for instance, we looked at Medicaid in California, SNAP in California, Medicaid in Oklahoma, etc. And we looked at the different questions or prompts for each of those states. So I would say roughly about 25, and we tested them in each state. Great question, thank you.
And on that note, we have actually released all of the prompts and the results from the models. They're all available in spreadsheets in our appendix. And so highly encourage exploring those and repeating those if people are interested in them or being inspired by them to ask your own policies questions as well. In experiment 2, we were asking eligibility questions to the API, guided by the policy document. So to do that process, we actually had to extract and consolidate the policy documents, as many are not actually AI ready. In the report, we have a table that explores the strengths and weaknesses in specific documents and some recommendations on how to make policy documents more AI ready. We then built a retrieval augmented generation or RAG environment, which allowed us to use those very specific policy documents with the GPT-4 API. And then we had a similar evaluation rubric looking at accuracy, completeness, and relevance. And generally, the model was returning relatively accurate results. However, the scores drop off significantly for completeness and relevance. This is results just from one state, but it's pretty representative of some of the patterns that we see. Similarly to experiment 1, that means while the response may be accurate, it's likely missing key information that would help you actually make a decision or action about SNAP or Medicaid. Some of the common completeness errors we saw include missing details for eligibility or a focus on administrative information like timelines or verification. And we saw some common relevance errors like off-topic answers or irrelevant elements. And I'm going to pass to Kenny to tell us about experiment 3. It looks like these got out of order, but we'll go here and I'll go back and then we'll go forward.
Yeah, I think they were in the correct order. Yeah, I moved them like a few minutes before the presentation. Yeah.
Okay, you want to talk about the template first? That's fine.
Yeah. Yeah. Thanks, Ariel. Yeah. So in experiment 3, we wanted to evaluate the abilities of LLMs to automate another essential component in the rules as code pipeline, which is like examining how well LLMs can generate programmable rules for different policies. So after a few early tries in the experiment, we realized that having a structured template of rules was the key to getting like reliable and consistent outputs from the LLMs. And it's also useful for replicating results or system auditing. So we designed like a prototype template where we clearly define these rules and along with the data type that the LLM should return for each rule. So a snippet of this template is shown in this slide. You can see. So in the case here of the SNAP program, this is like a simplified snippet of the template that we used, and it captures like some eligibility criteria, like income limits and work requirements. Next slide, please. Yeah, so using this template at that point, it becomes the LLM's task to just fill out this template for each policy and state with the accurate and up-to-date values. So we explored two different strategies. In this experiment inverse approach, we used the standard GPT-4o model, and we just prompted it to generate the values for the rules in the template without any access to external information. In the second approach, we used the same prompt, the same model, but we added the RaC framework, which gives the LLM access to a search tool that it could use to query information from an indexed database, which contains relative state policy documents, and then the retrieved documents from the database could be appended to the model's context to guide its rule generation. Next slide, please. Yeah, so we evaluated the results from both approaches by comparing their output to ground truth values that we manually verified in our team for SNAP in 3 states, Georgia, Pennsylvania, and Texas. And as you can see in the table here, the plain prompting approach, the first approach, it produced and especially for the rules that like differ across states, like income limits and asset limits, like these are numbers that are like different for each state. So we can see here like most of these criteria, like they failed in the plain prompting approach, but for the RaC approach, it led to much better alignment between the LLM generated rules and the actual policy documents. That being said, however, the RaC framework still struggled with like instances where it cannot retrieve the target documents from the database, or when these documents don't even exist in the database. So we had like 2 main takeaways from this experiment. First, having structured templates is essential for rules extraction, and second, rules generation, like in this experiment as a separate component, can provide a very strong structure for automated code generation. Next slide, please. Yeah, so moving on to experiment 4, where we examined how well can LLMs write code for benefits eligibility. We focused in this experiment on a small targeted task, which is determining worker registration eligibility for SNAP in Georgia. This is like one of the criteria of the SNAP program. And we just like to use this small task to like narrowly focus on the LLM's capabilities and like be able to analyze the results. And we used 3 different strategies to analyze the code generation performance of LLMs. In the first design was just like our baseline. It involved just prompting the LLM, same model GPT-4o, along with the relevant policy excerpt that is like relevant to the task that we have, and we just asked the LLM to write code that determines the user's worker registration status. So it would like take input from the user and output their status using like the code that it writes. And then we reviewed the output from this experiment, from this approach, and we noticed like several issues with the output. And then we, for the second design, we like looked at all these issues, and we developed like a detailed set of instructions that aims to correct some of these problems that we observed and like try to steer the model closer to get like more expected output. So we appended these instructions to the prompt along with the policy excerpt, like the first approach, and we ran the same experiment. And then for the third approach, we tried something a little different. So we created a more structured pipeline for code generation, where it's not just one single shot. Instead, we have like 3 main stages. First is policy summarization, then pseudo code generation, and then we generate the final code. And each step's output is the next step's input. And the goal here was to break down the task into like individual steps and assess the model's performance at each stage of the code generation process. So like, for example, in the summarization step, we wanted like to evaluate the model's ability to extract key information from the policy documents and like restructure this key information like better into something that would aid code generation. And then in the pseudocode step, this tries to get at like the model's logical reasoning abilities and how well it could turn the extracted policy information into a set of decision-making steps. And then the final code generation step, it tries to like tests how accurately the model can translate the pseudocode from the previous step into executable code while still like keeping the same, keeping the policy context in mind. Next slide, please. So yeah, we evaluated the output from each of the 3 approaches, and we summarized the results using key qualitative metrics in the table that you can see here. At a very high level, we saw that the second approach, the one with the detailed prompt, this one performed the best in terms of like code quality, accuracy, the accuracy of the output code. And we also observed that the baseline approach, like non-surprisingly, it had the weakest performance and it had the worst code quality, but it still served as a useful and informative step for us to for like prompt engineering for the second approach. And then the output of the third approach, the multi-line step pipeline, it was a little bit more complex. We did see improvement, like which we expected. We did see some improvement in performance at each stage, but like a major challenge was error accumulation and propagation from one step to the next. For example, like if the model makes a mistake in the pseudocode step, this mistake will be carried over to the code generation step, and then you will accumulate like more steps down the line. Yeah, so this was like the major issue with this approach. However, we also know that the modular design allows us to debug and correct errors at each step, which we think is like more difficult to do with single shell pipeline.
Thanks so much, Kenny. So some high-level takeaways, and we're obviously very happy to take detailed questions too about any of the experiments. But asking our hypothesis was, can LLMs actually help us with the rules as code approach? Yes, we believe LLMs can help support the rules as code pipeline. That said, it's really important that we have to keep humans in the loop, especially when we're working on high stakes benefit systems, that accuracy and equity outweigh considerations of efficiency. And so wanting to make sure, especially that our government colleagues hear that loud and clear. The source on authoritative sources is also really important, and it is possible to improve the quality of the LLMs by pointing directly to those actual authoritative sources like policy manuals. However, a lot of those policy manuals, as I mentioned, are not AI ready, and so it's really going to be up to government as the author of those policy documents to make them easier for LLMs to consume. And when we ask LLMs to write policy code directly, it generally leads to poor code. But as Kenny was sharing, the code generation can be improved by using an LLM with RAG to generate machine-readable policy rules. But that still really requires that manually curated template. So not a full automated pipeline, but one that has some human touch and love along with it can help us. We also wanted to just really note some of the impacts on people that we're seeing from these experiments. So those mixed LLM results have a direct impact on people seeking or receiving benefits. It's risking a lot of incorrect or incomplete information when they go and ask generative AI models questions about programs like SNAP and Medicaid. We had a really good discussion in our Rules as Code community a couple weeks ago about should we or should we not use AI in the benefits context for these web-based chatbots. it's here and now, and people are using them, and people are asking them questions about critical programs. And so I think it's up to all of us as practitioners in the space to help those models get better at answering those questions, and government to make those policy documents digitized and ready for AI. The other thing to note, I think you've all probably played with some chatbots, but they have a very confident tone, even when they're presenting information that is not quite right. And I think it can really mislead people who are looking for trustworthy information as well. And so all the more reason we need to improve the information that's getting shared through those chatbots. All of our work is open and shareable, and one of the things that we really want to encourage is ongoing experimentation in this space. So being able to repeat the methodologies for other states, countries, programs, policies, LLMs. We've set up a framework that could work and could be applied in lots of places and kind of wider context. It's obviously also very easy to repeat the methodologies for different programming languages for the actual outputs. We would love to see also more pairing between policy experts and software engineers to program and evaluate the results. Could also explore more specific program or policy LLMs. One thing we don't have access to as researchers on the outside of government is comparing rules against existing systems, but that would be something we'd be very excited to partner with government on, as well as exploring extracting code from legacy systems and seeing if we can translate to a more modern language and rule set that's based on that historic logic and knowledge. And then I think also really continuing to look at the trade-offs between the time spent code writing versus the time spent code analysis on generated code, and are we saving time, or are we just shifting where the work happens? And so we're eager to continue to explore that. But as I mentioned, our full report is now available at this link, and I can drop it in the chat as well. We also have a shorter edition that's summary and key takeaways that's a little bit faster read. And then in the appendix, you will find the rubrics, the prompts, the results, the scores, and some of our code samples. And that's all open licensed. We would love you to take it, use it, reuse it, play with it, whatever works and you're interested in. And so appreciate you all giving us the time. As I mentioned, we also have a Rules as Code community. You can also find the Digital Benefits Network on Blue Sky and LinkedIn, and email us at any time at rulesascode@georgetown.edu. And that's it for our presentation. I'm happy to open to questions.
Wow, awesome piece of work. And I'm sure it'll get referenced a lot from, a great number of this community for sure. And I'm sure the word will spread. Questions, anybody? I have a couple that I'll ask if nobody else has one to kick us off.
Yeah, I do have a quick question. The question I wanted to ask has just completely disappeared from my head, which is great timing. I hope it'll come back soon. But I'm just wondering, I think it's a really good approach, just going through and actually looking at multiple approaches back to LLMs rather than trying to do the one big leap. But have you started looking at some different open source models? So if you jump onto Hugging Face and just have a look at some of the models that are maybe more tuned to policy and replacing those in your policy review step, taking a look, personally, I think the Anthropic models are doing better around code generation. I'm getting mixed results out of Gemini. Like, when it hits, it's brilliant, and sometimes it misses pretty bad. And then one of the things that Gemini is really good at, so if you were to use, say, like Claude 3.5 or something for your initial code generation, and then run Gemini over the top of that and ask Gemini to fix the code, Gemini's really, really good at code review and editing. I think better than Claude. So that mix of models, I think, might actually help.
super interesting. I will say it was mostly a time thing. We had started with a larger list of models that we had hoped to test, and we narrowed that extensively to be like, let's get the methodology down and document it and the results, and then know that we can come back over it with other models. It's also, there's been like releases in models since we were doing a lot of this research and making some great leaps forward. And so it's been really fun to talk to other practitioners who have been working with some of these tools to be like, we're seeing just better general results out of this model over this model. And I had never actually heard the telling Gemini to fix the code. Kenny, I don't know if that has come across your radar, but that's a very cool technique.
Yeah.
Me?
Mm-hmm.
Oh, yeah, you saw me. Oh, rolling. So I have run out of room in the Google Meet of all the questions I want to ask. So thank you for the great presentation. I might just hit send. There's 3 key questions and then my 4th, and just take what you want to talk to. I don't want to flood the Q&A, but anything that you think that's there that's worth talking about. I think one thing that I hadn't expected to reflect on was sort of you talking about the role of just public unmoderated AI services and how, you know, that is the forum that lots of the public will increasingly consume this information. And that was sort of quite interesting to me to flip my thinking around how you could perhaps influence those off-the-shelf models to do a better job assessing entitlement. So that was just sort of my wondering there. And I'd also be curious to know if there's any research or influence on like the different demographics who may be using ChatGPT and those who don't, in the context of, you know, benefits entitlements and, you know, marginalized people who would be entitled to support versus, you know, mainstream or wealthy users. So sorry, that's a terrible asking 6 questions / comments. But if there's anything in those that you'd like to comment on, Ariel, or your team, I'd love to hear your views. But Joe, I won't for 20 minutes.
You, Josh, I can't moderate you, and they're all good questions. Good questions. Ariel.
Yeah, I'm happy to take some of that. I haven't actually seen research on who's using chatbots and models. I think there's like seeking out ChatGPT, but now like if you do a Google search, the top of the page now is a Gemini result. And seeing those cite their sources and also use sometimes a very interesting combination of things to get you an answer. And you see the stuff that goes viral that's like silly that comes back. But I mean, I actually find it pretty useful frequently for stuff I'm looking for, or like looking for a something to point me in the direction of some other research. So I would be fascinated by that. I think one of our other areas of research is on digital identity. And we did like a very extensive lit review to see if anybody had been writing about the experiences of low-income people with digital identity, especially in the US, especially around seeking benefits. There's stuff in the like quote developing world on digital identity where like people are really underdocumented and there's really deep poverty, but there wasn't kind of the seeking benefits side of it. There's been a little bit of research in the UK, but we found that like a lot of low-income people plus technology experiences are very underdocumented in the US. So we've been trying to fill some of those gaps. And then the other really fun thing that we have in the US is that we have national policy. So SNAP has a federal policy. It has a federal agency that oversees it. It is determined by Congress through the Farm Bill, which comes up every 5 years. They keep pushing the current one back. But so there is a policy body around it. And then the Food and Nutrition Services actually implements it. They write a lot of guidance and rules around it. And then states also have their own policy manual. So they take kind of, I'm oversimplifying, but they take the core federal policy and then adapt it. And then the federal government also gives them waivers for different things. So for different populations, states wanting to be more inclusive or more restrictive, there are bounds of some of those things and how they work. There's also states that have higher costs. I actually live in New York state, not in DC. It's higher cost of living. And so the household income sizes and ranges are different in New York than they are in other states, for example. And so it creates a lot of variability. And it does mean there's kind of like a core set of qualities that the policy is looking at and a rules engine and set of rules would be looking at. But there is the state to state variability. But that's something where we think AI can really help us. If we have that template of those core qualities, AI can help us plug the right values and data back to them on a state by state basis. I feel like I got part of your question.
Yeah, I think you characterized the general challenge. I mean, there's obviously several research programs just on that question, right? So, thanks. It's fascinating to look at that. I myself am from New Zealand and do work in Australia, and appreciate not having a federal and state divergence regularly in terms of the clarity with which we can kind of target getting the thing done.
Yeah, and it's not even that there's just 50, well, there's like 50 policies, there's more than 50 policies because of the territories too, but there's actually, it's like 150 something unique applications for the core 6 benefit programs in the US. So it's not even just one state has one application, most of them have multiple.
That's a very complex structure.
Mm-hmm.
So the other questions there are great questions. So the cost, I'm assuming that there are benefits to being at Georgetown University in Washington DC, but is there, we've had a presenter on the Rules Code, the RaC Guild, who did some kind of cost benefit analysis of Rules Code, not of AI, with Rules Code. But yeah, is that something that you've looked at or will be?
It's kind of in that question on the trade-off of the policy analysis versus the code writing versus code analysis question. I don't know that we're going to do like a true quantitative measure of it, but I think it is something that's really interesting. And I think something we're very interested in general in like government service delivery is when something gets digitized, it might save time in one place, but then create new issues elsewhere. So like in our digital identity work, it might create some efficiencies where people can like have an account, but then all of a sudden people are calling the call center and they're all backed up in the call center because people are calling about the accounts and there's no one who knows how to deal with the accounts in the call center. And so I think we're really interested in some of those like multi-factor problems that start to happen when we do create efficiency in one spot. Does it actually have these like follow-on effects elsewhere? And I think there's a lot of evidence building that's needed to convince states that, automating parts of this can help. I also, there's not a lot of transparency in these systems right now. So it's also really hard to tell entirely from the outside really how accurate they are. And so there's also could we be using AI and Rules Code to help bring more transparency to the systems, but does that create its own set of oversight, compliance, et cetera, issues as well? So,
yeah, that was one of my questions: is the code accuracy, but actually the legal accuracy of the rules, and assessing, completeness, relevance, doesn't speak to legal accuracy, which is another whole different group of people to assess that. Could you just, for the RaC Guild, and for people watching this recording later, the code that you're outputting, dumb basic level question, what code are you outputting for what? Doesn't matter that it's Python or anything else, but what code was that you actually output?
Kenny, do you want to take that? I feel like I've been talking a lot and these guys have good answers for you.
Sure. Yeah, so the output of experiment 4 is a Python script. And so to do what? It takes input from the user, which the LLM decides. So it's part of the prompt to figure out like what input it needs from the user and like what data types is required for like this input. And then it would like take this input and along with because it already has like the policy excerpt that it like kind of like integrated into the script. And using this input, it would evaluate and like determine if that user, the status of the user, like for work registration, which is one of the eligibility criteria items in the SNAP policy, which is like it determines like if that user, if that applicant is required like to show proof of work, if they like pass a certain age. So it's just like a subset of the program. It's not all of it, and it determines based on the user's input of their like personal information if they are required like to submit proof of work, if they are like exempt. Maybe it could be like exempt from the whole like work registration process. And like more details on this is in our report. Yeah.
Thanks, Mohamed. So essentially, it's churning. What you're churning out could ultimately be a user interface for somebody to plug in their details, or
Exactly.
for an official to use sitting with somebody to plug in their details. So very similar to the original project that we started this off with the Citizens Advice Bureau, providing a tool for advocates to tell people what they were entitled to. That's what you're outputting. Yeah.
Right. Yeah.
Yeah. Cool. Yeah, Jaden.
Thank you so much. Like, this work is amazing, and I did a very similar project. Not on ChatGPT. We used We didn't use OpenAI. We used an OLAMA, like local offline model, and this was done about this time last year. And I think Kurt already covered my question, which was about if you'd experimented with that sort of thing. But I guess, did you experience any instances where ChatGPT would introduce another different piece of legislation that you didn't ask for? It would ask, like in our experiments when we did it, we found that it was introducing random pieces of information, and it was big because we didn't provide it enough context. So it was trying to just guess at what we wanted. But when we used an instruct model, and then we also use RAG, and we had a schema that it had to answer to. So a set of rules that were the top priority for the model. And we found that by doing that and having it basically trained on exactly what we wanted, it wouldn't even try to, I guess, extrapolate this random information that we didn't give it, and it would say, I need more context or something like that. So I guess, were there any instances where you found that with ChatGPT? Because I guess it is such a broad model trained on so much.
Yeah, Jason, do you want to take that?
Definitely. Yeah, so the answer is yes. Especially for experiment 1, where we were relying only on ChatGPT's training data, we saw quite a few responses where they were pretty inaccurate. Now, we didn't go back and trace where ChatGPT may have gotten its answer, so I'm not sure if it was which legislation it may have been taking from, if it was taking from legislation at all or just hallucinating, but there definitely were cases where it appeared that it was really pulling from a policy that didn't have anything to do with the programs we were testing. And I think to sort of speak to what you mentioned in terms of it getting more accurate and not pulling from other policies, with experiment 2, instead of relying on training data, as you mentioned, we fed in the authoritative source documents, and we saw some improvement in terms of how accurate the answers were. But then one thing that we really struggled with in that experiment was that the documents that we had states, this might be a quirk of how all programs are administered in the US, but given that the states all had different policies, they also have all different ways of organizing their policy documents. And some documents contain policies for multiple programs. And so the chatbots or the LLMs would struggle with sometimes identifying, even when given a document, identifying which program a specific rule within that document might be referencing. So that was a challenge that we saw. It might be based on the quirk of the state system in the US, but that was something that was interesting to us. Kenny, I don't know if you saw anything else related to improving how GPT performed in your experiments.
Yeah. There is, if I could add, like there is one like particular example that we observed in experiment 3 that kind of like resonates with what Jaden just said, which is like when we added the RaC architecture to the experiment, we observed that like when we append like the resources, the retrieved documents to the LLM's context, it would assume that like whatever information it needs to answer, like whatever information it needs to return, exists in this context, and would like kind of like refuse to consult its whatever it did like knew from training. So even like it could be, you could ask it about something that it would like know in it, like that we know that it's in the training data, but like because we failed to like include it, or like it failed to retrieve it from the database, it would like kind of like to that information from the context that you provided, because like in the instructions you kind of like said you have all the information that you need to like answer like the question, to answer the query. So it would like kind of like fail to fall back on its training data to retrieve the information that like failed to make it to the context.
Cool. Yeah, we have a very similar problem in Australia where we have legislation that is written very differently for very different contexts, and some of them are hundreds of pages. The one that I used was farmhouse farm allowance scheme, and it was 80 pages. And by putting the whole thing in, one, it took ages because we were using a local model, and the GPU with compute wasn't the greatest that we were using. But it had such an issue finding that eligibility criteria, which is the key thing for rules as code. You need that black and white rules. So we ended up having to cut down exactly what we said, this is the eligibility criteria, and we had to manually feed that in. And then we also gave it the context, such as the definitions on the top of the document. But then if we looked at social security policies, again, they were different. So I guess I wanted to come back to a question that Josh asked, was the template. That template, is that a standard thing? Is that something that you custom create for each policy? And is this kind of a schema that you use for the rules, or like what context do you use the template for? And is it the same thing across all?
Yeah, it's not like exactly the same thing, but I would imagine like for the same policy for different states, it would be like similar, but like it would have to account for like the differences across states. But like this template is just like our attempt to formalize how these rules are listed and to get consistent and reliable results from the LLM. So instead of just like asking the LLM to take whatever documents and generate whatever rules it thinks exist in the document, which like if you try this multiple times with like multiple LLMs, you will get different rules and different namings for these rules. So there is no way to like get this output and kind of like integrate it with other systems, or even like have any kind of automated evaluation for that output, because like it would have different rules and so yeah, what we did is just like, we want to standardize this. We want to be able to look at the output from different states and from different policies, and we want to like know that we want to know like what to look for. We want to compare that against something that we can verify by like manually getting these values ourselves, like looking like literally just like looking at these same documents and getting our extracting the values ourselves, just to have like a framework that we can evaluate the performance of the LLM. So it's custom made. I would say like for every policy and for every state, there has to be like an organization or like a team that would agree on these rules. And yeah, so like and in our case, like this template, like we cannot make it as comprehensive as it could, because like there are like many many rules that you have to account for. But it was just like the first step to actually like having this in kind of like a standardized way.
Yeah, I think that's the challenge is if you want to use rules as code, there's still so many manual things. Even with AI, there's so much that we have to do to, I guess, make sure that is a consistent, valuable, accurate output. I guess just on a similar vein, recently, so I'm in the Australian Department of Finance, and we're doing rules as code, we're productionizing at the moment. We presented what we'd done to one of our executives, and he was, because he'd only been briefed very high level before, and he said, "Oh, I thought it was magic. I thought it was, you just run it through and it'll all do it." And we said, "No, it's a very manual process." And because he said, "Oh, what if we just put through 100 pages of Social Security legislation?" And we're like, "No, there needs to be those checks and balances." So there's interesting conversations with what's assumed. So I guess it's all about, how are we going to communicate that this is not something that we can just run through AI. There has to be these, we need a framework. We need a structure of how we're going to put it through AI and have those human checkpoints. Because there are people out there that will just, if they get the chance, they'll put everything through there and then they'll say, "Oh, this is the source of truth created by ChatGPT." So it's very interesting.
Right.
Josh, go.
Yeah. Look, I just strongly agree with what Jaden is saying, which is that view is in the general professional development advice being actively espoused, so there's this cautious, rigorous application of AI kind of at a practical level that you're talking around. And then there's significant institutional social pressure to not be a Luddite and just apply AI. So, I mean, I guess to bring that back, like I'm pleased that you are publishing research that can provide something, a little beyond our individual efforts and projects to provide a little context to that. And also if there's some blowback because someone decides to pump Social Security through AI and then, I don't know, lay off all the safeguards, that you can sort of talk about responsibility in digital services. So, without that, research that you're actually publishing, it's a much more difficult to have a, clear discussion about the different approaches. I just think it's really interesting looking at that. Like we've looked at like something analogous to what I assume Jaden is trying to do, which is try to publish AI assisted good guidance to the public, on your platform. Conversely, ChatGPT free version being where a significant amount of traffic is getting that advice, regardless of how flawed it is or incomplete or anything like that. So it's quite interesting to me. And I almost wonder if there needs to be language separating out those approaches that's a little more accessible than like RaC, which, So I think there's scope for you to create messaging frameworks so people can engage with that as executives and say, no, don't get rid of all these guardrails and just, not think because AI is trendy, that there are all sorts of bad decisions that are supported by, keeping up with trends and technology development within it. So thanks.
Yeah, I strongly agree. I mean, we were already doing this work and, we're pro-technology, like we study digital service delivery for benefits and we work with states on implementation. And so we're not anti-technology. I think there's like a big anti-digitization and like anti-tech movement that's like no AI, only fairness, et cetera. And like, we need to be considering those things. But we also think that technology plays a role in modern government service delivery. But we were at, in the fall, we were actually presenting the wider policy to code research at a conference, and I went to a session afterwards that was a vendor, and it was like 45 minutes of them telling states they could automate every single part of their benefits delivery process from first interaction to end delivery. And I was just like, this is so wrong. I actually complained to the conference organizers because I said, this isn't accurate, and our research shows otherwise. And I support technology. And so we need to help states on that journey and not have them just sold something that's not going to actually deliver on their mission either. And so I do think we play a little bit of a unique role in the ecosystem, and that we're at an academic institution. And so we're able to use our seat and do research and our voice of influence on that. I'm a former government practitioner, so I've been in deep in the work of doing implementation of these systems, and then bringing kind of the latest and greatest of what's actually possible with the technology. So super grateful for you all, and have learned a lot from a lot of the work in Australia and New Zealand. And Jaden, if you don't mind, I think we would love to follow up with you to learn a little bit more of some of the things you're learning as we move to the next stages of our research here as well.
Yeah, definitely. It would be great to keep connected, because we had a very similar approach from a company that said they can do end-to-end rules as code with AI. And there were some people that were going, oh, this could be interesting. And instantly I was thinking, no way. Like, that is just totally the opposite of what we want to be doing. And I asked them, where was the human in the loop? And they said, oh, you could put a lawyer in this stage. And it was like they hadn't even thought about it. And I was just kind of astonished that they had the guts to come to us and say, oh, we have this product. And I was like, it's totally the wrong kind of mindset that they're coming at it at. So yeah, I'll just put my email in the chat if you want to, start a conversation.
Thank you.
There's also the so good timing, and thank you for the segue, Jaden, because it's the top of the hour, so we're already 15 minutes over what we intended. There is also the Slack group. So RaC Guild has a Slack group. I don't know whether Ariel, Kenny, and you're all part of that, but it would be great to have that conversation in public as well, because there's obviously a wide interest in exactly this. Ultimately, what we need to do is write rules better in the first place, right, for human and for computers, and finding the right prompts for public servants and policymakers to do that piece of work is the prompts that I think we really, really need right back at the generation stage of making decisions in the first place. Hey, thank you so much for explaining your journey. Hopefully the work will continue, and we will see you again very soon with the next iteration on this project. All of the details of the Georgetown research will be on the RaC Guild website for anybody to refer to. As I said, please do join the Slack channel. There's an invite on that website as well to join the Slack channel. We will be again here in May. So it's the first Wednesday of the month, and we swap the time zones so that we can get enough participation across the world. So next time it's not morning in New Zealand and evening in Washington, it's the other way around. And we'll see you on May the 7th at 9 a.m. Australian Eastern Time and 7 p.m. 9 a.m. and 7 p.m. What's that? I'm confused. Oh, it's just it's alternating. I get it. From our Australian host's perspective, that's what it is. We will see you next month. Thanks again, Ariel, Jason, Kenny. Awesome. Appreciate your time.
Thank you so much,
Thank you
guys.
so much.
It's a great presentation.
Thank you.
Thank you all.